LISP, any source, multicast, or ASM. In the previous video, we learned about the LISP source specific multicast, and we know that we have another type of multicast routing. We call it ASM or any source multicast. And let me to say that the prerequisite of this video is the multicast or is the any source multicast in the IPv4. Okay, because of that, if you learned about the ASM, you can watch this video and you can learn about the ASM in the LISP environment. First, let me to review some of the topics that we need to know. After that, we can start to talking about the any source multicast. First, about the concept. After that, we will configure this scenario. Again, let me to say that in an enterprise or data center network environment, it is very common to have application with multi-destination traffic, that is traffic destined to multiple end users or receivers, which might be geographically dispersed. Most of these multi-destination applications use multicast, and thus it is vital that the infrastructure be capable of carrying multicast. LISP infrastructure also provide support for multicast traffic, and you know that we have some differences between the how LISP handles unicast packets and how it handles multicast packet. We talked about that in the previous video. You know that about the unicast we need mapping of the source and destination, but about the multicast we need the mapping only for source. After that, let me to give you or review some of the concepts, some of the basic terminology we need to know. After that, we can start talking about the ASM in this video. Look at here, we have six definition. Let me to first start with the source endpoint identifier or SEID. Assume that the server S now is want to send the multicast traffic. This is the server, and this server has one IP address. We call it SEID or source endpoint identifier. The SEID is the source host. Okay. After that, we have receiver endpoint identifier or REID in the ASM. For example, PC3 and PC4 are receivers, are viewers of this traffic, and because of that, the EID of these two PC, for example, PC3 and PC4 are the RID. After that, we have source routing locator or SRLOOK. SRLOOK is the RLOOK of R1, okay? The XTR that connected to the LISP site that the source is residing in that LISP site. After that, we have receiver routing locator or RRLOOK. The RRLOOK, the RLOOK of the XTR3 and XTR4 in this example, because we have receivers in these two LISP sites. Now we have another new definitions. The first is rendezvous point endpoint identifier or RPEID. You learned about the rendezvous point in the multicast course or multicast video. The rendezvous point endpoint identifier is the host where the RP resides. Look at here. Assume that in this scenario, the R10 is our RP or rendezvous point, and the EID of this, for example, the EID of the RP is the RP EID. Okay, and after that, we have rendezvous point routing locator, and again this is the routing locator of the RP, for example, routing locator of R10. Assume that here we are using the R10 as the RP. Because of that, we have one RLOOK and in Rotor 10, and that is the RP RLOOK. And if you are using one IP address for RP, for example, quad 10, okay, or one another IP address, that is the for example RP EID. It's so easy. Okay, after that, let me to review some of the process that is occurring when we are using the any source multicast. This is only review of the process, and we expect that you learned about this process in the multicast course. Because of that, if you didn't learn about the multicast routing, any source multicast routing, you can't understand the detail that I am going to mention, or I am going to review them. But if you learned before about the any source multicast, you can easily understand the process that I am going to talk about that. As you can see here, we have a server, and this server now should send traffic to the destination multicast group of the 226.111, for example, and the source IP of this packet is 192.168.110, the IP of the server. This is our packet, our multicast packet now is sending from the server S. Let me to show you. This is our packet, and now this packet is reaching to the router 1. Okay, in this scenario, as you can see, the router 1, okay, is the router that directly connected to the server, but maybe in some scenarios, okay, we have another router between the XTR and also the server. Let me to show you. Look at here. Assume that we have a server in this list in this site, and this server connected, for example, to the router X, and then the router X connected to the R1. Okay, R1, you know that the R1 is our XTR, ETR, and also ITR, and here the RX is the FHR. Let me to write here. This is the FHR. This is a term about the multicast, not about the LISP. FHR means first hop router. Okay, first hop router is the router directly connected to the source. Okay, but here, as you can see, the S directly connected, the server directly connected to the R1. Because of that, the R1 is both XTR and also first hop router, the router that is receiving, that is accepting the multicast traffic. Okay. And also here we have the PC3 directly connected to the XTR3. Let me to talk about that. You know that the PC3, okay, in this scenario directly connected to the router 3 as the XTR, but it's possible to router 3 connected to another router, for example, router Y, and this router is the LHR or last hop router. Again, this is the term of the multicast, not about the LISP, but it's a good practice to talk about them, to understand them, because maybe in real scenarios, in real world, you experience these conditions that the receiver and also the server are not directly connected, or for example, do not directly connected to the XTR. Here we don't have any problem because you can enable any source multicast on these routers. Again, we have the same process. The process of the LISP is same, but maybe we, for example, experience some other configuration between the server and XTR. Okay. And now, as you can see, I'm going to talk about the process that is happening when we need to receive this traffic, the traffic from the server into the in the PC3 and PC4. What is happening? Let me to talk about that. You know that the first thing that is happening is that the receivers or receiver, for example, PC3 and PC4, should send one IGMP join for this group, the group 226.111. Let me to show you. Okay. Here, you know that here, because we are using any source multicast, we can use IGMP version 2 or IGMP version 1. In most cases, we are using the IGMP version 2. This is the IGMP version 2 join message for this group. Let me to write the group. The group is 226.111. Okay, and this join group now is sending from the PC3 to the router. Okay, and also the same process is happening in the PC4. I'm going to show you only the process of the router, the PC3, and you can yourself again do the same process for the PC4. Okay, let me to review. The PC3 now means the receiver. This is the receiver. When I say the receiver means the PC3. Okay, the receiver sends the one IGMP join, okay, for this group 226.111. Okay, PIM join packets are created by the LHR. You know that here when we are sending this join message to the router tree. Okay, the router tree as the XDR directly is receiving this join message, but in some cases we need to create the PIM join message. Let me to show you here. Look at here, between the LHR and the XTR we need the PIM. Okay, after you sent from the router tree, okay, IGMP join. Let me to show you, this is the IGMP, okay, join for the for example 226